What is Lakehouse in Microsoft Fabric? Hi, hello everyone. I'm Naval Yamal. Welcome back to my YouTube channel Data Master and welcome to the playlist on Microsoft Fabric. In this video, we're going to talk about Lakehouse. So, what is Lakehouse? So, Lakehouse is a combination of your data lake and your data warehousing. Data warehouse. So the best part of the data lakes and the best part of the data warehouse, they have combined together and they have introduced this term called Lakehouse. So in Microsoft Fabric, Lakehouse is a data architecture platform that helps you to store the data, manage the data, and analyze the data. It might be a structured data or a semi-structured data or unstructured data, all in one single location. And Lakehouse helps you to manage large volume of data, and it can help you to process these large volume of data by using different frameworks. You can start analyzing it, start manipulating it by using the notebooks, by using a data flows or by data pipelines. And if you are someone who is looking for a data engineering and data analytics one, we generally use a lakehouse to store the data and to manage the data. So if you are following my playlist on Microsoft Fabric, I have created a workspace. So we talked about the task flows, then we talked about the what is data factory experience in the Microsoft Fabric. So I request you to please go back and watch those if you have not watched it. Let me go back to the Microsoft Fabric, and here I'm in my workspace and I have created a workspace called Data Master YouTube. Now we will be creating a new item that is called as a lakehouse for storing the data in a large volume. So as we progress further, we will be creating an item called warehouse also, and then we are going to see the difference between lakehouse, warehouse, and what are the different use cases, when to use lakehouse, when to use warehouse, and so on. Now let us try to create a lakehouse. So for here, you can just click on the item, and as I told you, you can create a different folders here, and in that folder you can create different items. So your workspace is divided into two sections. One is your task flow. So this will show you how your project is flowing. So we discussed about it. Now I'll just jump on to a new item, and once I click on a new item, so I'll just go down, and here you should see in the data storage we have a lakehouse option. So I'll just hit on the lakehouse, and the moment I click on the lakehouse, it's asking me the name. So what I'll do, I'll just say Data Master Lakehouse, and I'll try to create this lakehouse. So it takes few minutes, few seconds to create a lakehouse. And once you get a lakehouse, your UI looks something like this, where you will find the tables and you will find the files. So files, it can be your semi-structured, unstructured data. It can be your CSV file, JSON file, your Parquet file, your Avro file, or even it can be your PDFs or any files inside this. Structure, semi-structure, what I mean to say. Then once you transform that data, once you start creating a structured one like rows and columns, then we store them into the tables. So we store most of the time a structured data in this tables. So we'll find tables, but the format of table by default is a delta table. It's a delta. So if you are not aware of what is delta, so I'll give you the link on what is Delta Lake. It was introduced by the Databricks, and now it's an open source. It's not just a data format, but it's a storage framework that help you to bring the assets to your lakehouse. And there are many benefits. You can do the time travel. It can help you to get work with batch as well as stream data, and there are so many benefits with the delta. So whatever the files we are getting as a raw data, we try to manipulate them and store in the form of tables. And tables, the format of the tables is a delta tables by default. Okay. So if you want to get the data into the lakehouse, you can see get the data into the lakehouse. We have varieties of options. We can upload it manually, or we can start with the sample data. We have a shortcut. So in my previous video, I've explained it. I'll be creating a separate video on what is shortcut. In simple words, it's like your Windows shortcut. So we create a shortcut in the same way in Microsoft Fabric, we create a shortcut, and your data resides at a same source. For example, it's in your S3, it's in your Google storage, or it can be in your ADLS. Your data resides in the same. We are just creating a shortcut of that files or a raw data into your Fabric. That is shortcut. Data flows, we have discussed about the data flow, a data factory experience where we have data flows and the data pipelines. And we have other options also. We can create a new notebook to start working on your raw data. It's all about the PySpark notebooks. And we have a new event stream for real-time stream. We can use this. Now we can use a sample data to start loading the data or start getting the data into the lakehouse. I'll be using a sample data in few minutes, but let me show you. At the top we have few options, like we have get data. You can see we have various varieties of options how we can get the data into the lakehouse. We have one option called new semantic model. We have a open a notebook. So inside a lakehouse we can create a notebooks. You can create and open the existing notebooks. You can create a new notebook, and we have a manage one lake data access. So one lake is a data layer. So whatever the items and experiences you are creating in a Microsoft Fabric, that will be attached to only one lake. It's like a OneDrive. You can see at the top we have few options here, like we have a lakehouse and we have a SQL analytics endpoint. So what is this now? So to explain the SQL analytics endpoint, let me go back to my workspace here. I'll just click on the workspace. I'll go back to my Data Master YouTube. And if you remember, few minutes back we created a lakehouse, and the name of that lakehouse was Data Master Lakehouse. But with that lakehouse there are two items that got created. One is Data Master Lakehouse and the type is semantic model. So semantic model is by default created, and with that same name we got a SQL analytics endpoint also. So with the help of this SQL analytics endpoint, we can start querying the data. We can start, so if you have a tables, you can start querying the table by simply writing a SQL code, and it only accepts the query language, and you cannot manipulate it. Means you cannot insert a new records in it, you cannot delete it, you cannot drop it, and so on. It's just for querying it by using a SQL. So with this SQL analytics endpoint, we can start querying it. Whatever the data is prepared in the lakehouse, we can start querying that. So in few minutes, we are going to talk about querying that SQL, querying the tables by using this SQL analytics endpoint as well. So now let me get inside a lakehouse. I'll just click on it, and now we are into the lakehouse. So we can upload the files manually from your local machine. We can upload it. You can upload CSV, JSON, and so on. So if you are doing it, it goes to the files. It goes to the file folder. But I'll be using a sample data. So I'll just click on the sample data. As we progress further, I'll be using a data flows gen 2. I'll be using a data pipeline, a new shortcut to bring the data from outside, from the different sources, and store it into the files. Now I just clicked on the sample data, and you should see there is a adding a sample data has been successfully done. Oh, if I click on the files, we got some images and we got some sample data. So let me just click on the sample data, and wow, you can see in the sample data sets we got some CSV files, we got some Parquet files, we got some CSV and Parquet files are there in this, and we got some images also. So what I mean to say is you can upload structured, semi-structured, all kind of files, all kind of data in this files. Cool. You can see images there and so on. Now let me go back to the sample data, and let me click on this CSV here, and you can see the data here itself. If you are in S3, to look at the data, it becomes a little bit difficult here, but you can check the data sample in this files. So you can go back, you can query, you can check the other files. Obviously Parquet data is not readable, not human readable, so you cannot see the Parquet files. We need a data frame to read the Parquet files. We are going to see that. Okay, so we can upload all these files. You can upload it manually, or you can run a pipeline on top of it. Now what I'm going to do is I'm going to create a table out of it. So try to understand, when it is a data engineering, when it is a data analytics, so we basically create a pipeline that will help you to convert your source raw data to a to a final layer that should be in the table. So if it is in the table, we can start querying it for doing the analytics, or we can start creating a reports and dashboards on top of it. If it's a raw CSVs, Parquets, JSON files, we cannot directly create a report on top of that. So we try to create a table, and then we can try and doing analytics on top of it, and also we can create a report and dashboard on that tables. As I told you, when it's a table, behind the scene, the format of the table is a delta table. Now, okay, we have a raw files in the file section. How do I create a table now? So to create a table, there are many options. Again, we can do it by using a data flows. We can do it by using a data pipeline also, or we can create a notebook. In this video, I'm going to show you how to use a notebook and try saving it to a table. So for that, I'll try to create a new notebook. Click on new notebook, and once I click on new notebook, you can see on the left side you get all your lakehouse items. So we have lakehouse, we have warehouse, and so on. Now I'll choose a lakehouse, and in the lakehouse I have a data master lakehouse, and I had one table called public holidays table, because when we clicked on sample data, all the data has been loaded in the tables as well as in the files. Now let me go to the sample data, and in the sample data we have the folder like files, then we have a sample data. In that we have few files. Now I have a Parquet file and I have a CSV file. Let me take a city safety Seattle CSV file, and on the right side you can see it's all about the PySpark notebook. So if you're coming from a Databricks background where you have a Databricks notebooks, or if you're coming from a Synapse background where you have Synapse Spark notebooks, so similar interface, you can see we have a notebook here. You can use a different programming languages here. For example, your Microsoft Fabric supports PySpark, Spark Scala, Spark SQL, even Python, even T-SQL on the notebooks. So I'll be using PySpark now, because PySpark is one of the beautiful open source framework that helps you to do the parallel processing and so on. So if you have not aware of what is PySpark, what is Apache Spark, I have made a separate playlist. I'll be giving you the link on that. Now you can see there are a few details. You can see workspace default. So whenever we are working on the notebook, I mean Microsoft Fabric notebook, you might be thinking like, okay, if it's a Databricks notebook or if it's a Synapse PySpark notebook, we need a compute for that. We need to go and create a all-purpose compute. Then we need to choose what type of node we need, how many workers we need, what type of driver we need, and so on. But here you don't need to worry anything, because Microsoft Fabric is a software as a service. Behind the scene there is a compute that is created for you. You don't need to worry anything. There is one default default compute that is created for you. If you say that no, I want a bigger size, I'm dealing with a terabytes of data, yes, obviously you can go and create a new environment with a larger compute size. But how to create it, I'll be sharing you in the next videos. But now let us keep it as a default one. I'm talking about the environment. Then we have a option like connect. So we have a new standard session or a new high concurrency sessions. If you're dealing with large amount of data, we can go for the high concurrency sessions. And we have other tabs, like you can open the notebook in the VS Code, or you can add this notebook to the pipeline, or you can run a new auto ML run. So if you are looking for the machine learning and the data science, if you want to run the experiments on this notebook, you can do it directly in the Microsoft Fabric notebook by using this option. We have a Copilot feature also. I think for my subscription, I'm using a trial subscription. There is no Copilot now, but we can add it later on. Then we have a edit option, we have a run, and we have a view option here. Okay, I'll be exploring that. So now you can see we have a PySpark notebook. We can add a new code by just hovering your cursor below the command line. You can say cell or command line. You can just add a code, or you can add a markdown cell. I'll just add a code and you can see it here. And if you want to switch between the languages, yeah, your Microsoft Fabric allows you to switch between the languages. You can use this one. If I want to use Spark SQL, you can just switch it to the Spark SQL, or if you want a shortcut, you can use percent SQL. In Databricks, we used only percent SQL, but in Fabric, we use double, I mean, 2 times percent and then the SQL. Now, let me write a code. So I'm talking about PySpark, creating a data frame. If you're not aware of what is data frame, what is PySpark, I'll be giving you a few links in the description. Please check those and you will be familiar with the PySpark. Now I'll just drag it. You can see this beautiful feature, drag and drop it. Okay, I'll just drag and drop it. Oh, let me check here. No. Okay, I'll just try to click on these 3 dots. Actually, when you try and drag and drop it, it will automatically create a data frame. So let me just load the data by using a Spark. Oh, cool. Now it does it. Okay, so we have an option like, do you want a PySpark data frame or do you want a Pandas data frame? It's amazing. So if I try to click on this Pandas data frame, and you can see, wow, so it tries to create a Pandas data frame and also the Spark data frame. So we recommend using Spark data frame because Spark helps you to do a parallel processing. It takes up all the cores and does the parallel processing. It saves a lot of time. So, but you can do Pandas also in this. So let me delete this, and you can delete the cell in this way. Oh, let me go back and try to create this, load the data using the Spark one. Okay, it looks good now. Now I'll try to run this. Okay, so to run it, you can use a play button here. I'll try to minimize these all to get some more space. So a data frame is created. So we are using a sample data, CSV data, and we have used only the header equal to true. You should get the headers true without the correct column headers. So I can use one more option here. So at the very first time, it takes some time, but once the Spark session is ready, you can see the standard session is ready. It doesn't take much time here. And if you have running this, you can see behind the scene there is a Spark jobs that are getting created. You can go deep dive into these all and check how the jobs converts to stages and how the stages splits into the task. You can go in detail about that. So we will be going and talking about that in detail. So we use a function called display to check the output. So we are taking an action on top of the transformation. So we get a table view here, and we have a lot of beautiful features here. It shows you the statistics like how many columns are there, how many rows are there, and so on. You can create a chart immediately. This is amazing. You can immediately create a chart. You can start playing with this. If you want to talk about how many columns are there, how many count is there, and so on, you can create a chart immediately after the display. Okay, you can do the data wrangling here. So what is data wrangling? How we can use a no code or a very low code tool to do the data manipulation in the data frame. We will talk about that. And we have a few details like all your column date headers as well as the data type. As I told you, we did not use the infer schema option. So all the data types are of a string type because it's a CSV file. So what I'll do, I'll try to take this all, copy this, paste it here, and instead of header, I'll say infer schema, and I'll try to run this. So now you will be getting a correct column data types as well. You can see the date type has been changed, and you can see latitude, longitude has been changed to a double, and so on. And the beauty here is if you click on any one of the column, it shows you the complete, you can say, data profiling for that particular column. It shows you what is a count, what is a maximum, what is a minimum. You can see all the different columns, and you can check the details about this column. Really helpful when you are dealing with like when you want to inspect the data, when you want to check the data qualities. This will help you a lot. Okay, cool. So we got a data frame. Now can I do some transformation on top of it? Yes, you can do it. So you need to know PySpark for that. So if you are saying df dot with column, so with column will help you to get a new column, and here I'm going to use a column name called ingestion date. I want to check ingestion date and which date and time it got ingested. So for that I'm using a function called current timestamp, but current timestamp is a function, we need to import that. So let me import it. So from pyspark.sql.functions, I'm going to import all this. And what I'll do, I'll just try to create df1 equal to, and see, for the data frame I'm adding a new column called as an ingestion date, and in that I'm going to add a current timestamp. So I should get a new column with a name called ingestion date, and in that I should get today's date and time. So I've used the df1 now, and let me tell you, in Databricks we can use df1.display to get your results, but in Microsoft Fabric I don't think so df1.display will work. So it throws you an attribute error saying that data frame object has no attribute called display. So it works like a function only. It just works like a function, so you have to use display df1, then only it will work. Let me try to run this, and now it should work, and it should give you a new column. Wow, you can see it should give you a new column, that is ingestion date and today's date and time. It looks good. Now we got a new data frame. We can rename the columns, we can add a new columns, we can do the data transformations here. So I'll make a separate videos on doing playing with the raw data, doing a lot of data transformation, renaming it, aggregating, sorting, filtering, all those things later on. Now our focus is to take this raw data and store it into the table now. So let me take this df1 now, and I'm going to write it. So I'm going to use a Spark writer API, write dot, I'm going to use save as table, and I'm going to save this table with a name. So I need a name. So this is nothing but a city safety Seattle data. So I'll just copy it and I'll paste it here. So the moment I run this, you will be getting a table in your lakehouse. You will be getting a table here in the data master lakehouse. It will store it in the table format. Let me try to run this and see what happens. Yes, it is running now. Oh, cool. So you got a Spark job, means your syntax and everything looks absolutely fine. Let me do a quick refresh here. Refresh this. Yeah, I guess refresh is here. And you should see, wow, you can see. So from a raw file, I tried to create a table by writing a PySpark code. There are a couple of ways to do that. Now we got a city safety Seattle. I'll try to drag and drop it. Let me check. Yeah, cool. So the moment I drag and drop it, you can see automatically the data frame is created by using a Spark SQL. It's a table. It recommends to use a Spark SQL. So we are using select star from the city safety Seattle table, and we are going to display that. So you should get the same results. Yeah, it's done. And you can create a, or you can use a SQL command. For example, I'll write %SQL, and then I'll write select star from the table name. So city safety Seattle, and the IntelliSense is also amazing. Just you write 1 or 2 lines and you should see the complete table name here. Wow, you can see you can query it by using SQL here, you can query it by using a PySpark data frame style, and so on. Amazing. So from a raw file we created a table. Now let me take few more minutes here and let me go back. I'll try to save this notebook. So I'll just say the notebook 1, it is nothing but a city safety Seattle table, and I'll just click on save. Cool, it got saved. Let me jump back to my workspace, and you should see you have a notebook here, you have a lakehouse, and you should see in the lakehouse, you should see there are the tables. Let me refresh this and let me open this, and you should see there are tables now. So one table, that is city safety Seattle, we have created it. So I want to talk about this SQL analytics endpoint. So we are in the lakehouse now. If I switch this from lakehouse to SQL analytics endpoint, so if I switch this to SQL analytics endpoint, you get a new framework, you can say a new UI that will help you to write a query, like a SQL query. So you can see it's in the data master lakehouse. It's a lakehouse now, and whatever the queries you are running it, you can see all your queries in the queries tab. Amazing. So now why we need to switch it to the SQL endpoint? So try to understand, we are talking about data analytics. So data engineer tries to manipulate the data and store it into the table. Now data analytics want to query that. So you need a framework or you need a UI that is more onto SQL side. So for them, basically they try to query the data, they try to do the analytics on these tables. So we get the SQL analytics endpoint on every lakehouse you create. So I'll just try to hit on new SQL query, and this is simple SQL now. You don't need to worry about the notebooks, don't need to worry about the compute, don't need to worry about PySpark, T-SQL and so on. It's just a simple SQL. I'll drag and drop it here. No, not drag and drop. It's like a SSMS. You can just use these three dots and click on top 100 records, and automatically your query has been started now. Okay, wow, you can see. So we had added a new column called ingestion date, and you should see the ingestion date column here. So it looks amazing, and you can start querying it. For example, if you say I want to get oh, I have only safety here. Okay, let me take any one of this, like shed fire. I'll copy this, and here I'll try to write a query where your category is equal to shed fire. Let me run this now. I'll minimize it. Wow, you can see this. So you can start filtering it, you can start using a where clause and do all the things by using this SQL analytics endpoint. If you want to play this all in the notebook, yeah, you can obviously do that by just switching it to the lakehouse, and you can open a new notebook and you can start playing with this. So that's about the lakehouse. So I'll just have a quick recap. So in this video we have created a lakehouse. I wanted to highlight, once you create a lakehouse, you get a semantic model by default, and we get a SQL analytics endpoint. So in the lakehouse we have two sections, you can say. One is files, where we can store all kind of data, all formats of data. We use the sample data and we got all this data, raw data, and then we try to create a table, a structured one from this CSV by using a PySpark notebooks. So we talked about the notebooks, we tried working on the PySpark, and then we have used a reader API, writer API, and stored that CSV file in the table. And once we got a table, we tried querying it in the notebook also, and we also queried it by using a SQL analytics endpoint. I hope you enjoyed this. If you like the content, please hit the bell icon, please hit the like button, and please subscribe to my channel. See you in the next video. Bye bye. Thank you for watching again.